And just like arithmetic sequences, afterwards comes series. So now we're going to talk about how to find the sum of the first n terms of a geometric sequence, which we will call a geometric series. So I don't have a fun story like the Gauss story, but this is the equation to find the sum of n terms in a geometric series. And let's just use it. So I want you to find the sum of the first 10 terms of the following geometric series. We're going to use the equation Sn equals the first term times 1 minus the common ratio to the exponent n, which is the number of terms, divided by 1 minus the common ratio. And it's just plug and play. So for this one, you're going to put in the first term here. So the first term of this sequence is 1. And then it's got 1 minus. We have to figure out the common ratio. So common ratio, second term divided by first term would give me 3. So 3 to the exponent n. So we're finding the sum of the first 10 terms. So n is 10 divided by 1 minus 3. Okay. Again, plug and play. To find the sum of n terms in a geometric series, you have to know the first term, the common ratio, and how many terms. So it's actually kind of nicer than arithmetic because you don't have to know what that last term is. You just have to know the common ratio. But, tricky part, can you plug this into a calculator? So brackets are your best friend, especially if your common ratio ends up as negative, right? But this is 1 times, which won't change anything. So I'm going to plug in 1 minus 3 to the exponent 10. Then I'm going to hit equals. So I can hit equals, or I can make sure that whatever I plug in for the numerator is in brackets, right? Because I want this numerator to be divided by this denominator. So I've plugged in, I didn't do 1 times because I know it's just 1. So I just plugged in 1 minus 3 to the exponent 10. Now I'm going to divide that by negative 2 because I know 1 minus 3 is negative 2. But if you want to plug in divided by 1 minus 3, make sure you put bracket 1 minus 3 unbracket. So because you have to have the subtraction happen before you divide, which is the opposite BEDMAS. So make sure you include the brackets. If you've plugged this in correctly, you should get, sorry, I got to change back to blue. You should get a sum of 29,524. All right, pause the video and try the next one. Hopefully you paused it. Okay, and gave it a go. So maybe you got stuck, but that's okay. Again, I like to write my literal formula out first, just so that I make sure I'm plugging the right things in. So again, I'm finding the sum of the first 10 terms. My first term is negative 2. I've got 1 minus my common ratio. So the common ratio is going to be the second term, 6, divided by the first term, negative 2. A negative common ratio. So we're going to put in bracket negative 3 to the exponent 10 all over 1 minus negative 3. All right. Lots of places to make mistakes with this. It comes down to calculator error, or someone assuming that their calculator is doing things right, or someone trying to like overpower their calculator. So if you look at this question, technically the first thing I should do is negative 3 to the exponent 10. So maybe I should do that. Let's go slow. So we're going to go negative 3 to the exponent. Now my calculator automatically puts brackets around the negative 3, so that negative 3 goes to the exponent 10. So what happens is I've got negative 2 bracket 1 minus, now this is positive because it was an even exponent. Any odd or negative base to an even exponent comes out positive. So 59,049 all over 1 plus 3 is 4. Okay, so again, what I'm trying to emphasize is that negative 3 to the 10 has to happen before you look at this as negative, minus taking away a negative, right? Because this isn't happening. This isn't a minus taking away a negative. It's a minus taking away negative 3 to the exponent 10. And since this comes out as positive, we're actually subtracting it. Okay, so a lot of people try to go in here. I'm going to write this and hopefully I can undo. But a lot of people try to go like this. And they're like, oh, I'm taking away negative, so I'm going to make it a positive. And then their whole question is messed up from there. So make sure you're really good with your calculator to plug this all straight in, or make sure you do this first. Negative 3 to the 10 gives me a positive number. And now maybe you can plug that in. So negative 2 bracket 1 minus 59,049 unbracket divided by 4. Now you should get as your sum, sorry, that's just red. You should get as your sum 29,524. 4. You could plug this straight into your calculator. Just be careful, right? -2 bracket 1 take away -3 to the exponent 10. Look at your calculator. Did your calculator write it like this? Does it go take away? Does it put the -3 in brackets to the exponent 10 and then get your bracket? And I would even hit equals at this point, right? So this numerator gives me 118,096, and then maybe divide that by 4. Right? See what steps you want to do in your calculator, or just get used to how you feel with operating your calculator. But the moral of the story is trust the formula, trust your calculator, and make sure you can use it correctly. Okay, so the last thing here for sums is, can you find the sum in a sigma notation, okay, or in this summation notation? So the first thing you want to check is, of course, that this is geometric, right? If this is a test, it won't say find the sum of this geometric series. It'll just say find the sum. So you're like, well, is this arithmetic? Is it geometric? Is it none of the above? So I find a few terms. So I'm going to plug in k as 1. So I've got 2 times 3 to the 0, oh, sorry, I'm going ahead of myself, 1 minus 1. Which is 2 times 3 to the 0. So 3 to the 0 is 1, which would give me 2. The next term would be 2 times 3 to the 2 minus 1. So that'd be 2 times 3, which is 6. The next one would be 2 times 3 to the 3 minus 1, which is 2 times 9, which is 18. So right away, I can tell that it's not arithmetic because it goes space of 4, space of 12. So I check if it's geometric. If I take the second term and divide it by the first term, I get 3. If I were to take the third term and divide it by the second term, I still get 3. So I'm positive that this is a geometric series. So I'm going to use Sn is equal to a1 times 1 minus r to the n all over 1 minus r. The more times you write that equation, the more chance you have of remembering it. I'm going to find the sum of how many terms? Well, the number of terms is 12 minus 1 plus 1, which gives me 12. So I'm finding the sum of 12 terms, where the first term we decided was 2. My common ratio is 3, and n is 12. All right, test yourself. Can you plug this into your calculator? I'm going to do it. So 2 bracket 1 minus 3 to the exponent 12 unbracket divided by -2, I get 531,440. All right, so pause the video and give the second one a go. So hopefully you tried this on their own, and if you didn't, and that's okay, right? You can always wait for me. So the first term is when k is 3. So 3 times -2 to the 3 minus 3, which gives me 3 times -2 to the 0, which is 3 times 1, which is 3. The second term is going to be 3 times -2 to the 4 minus 3, which is 3 times -2 to the 1, which is 3 times -2, which is -6. I can find another term if I want, just to make myself feel better. 3 times -2 to the 5 minus 3, which would be 3 times -2 squared, which is 3 times 4, which is 12. All right, so what's that common ratio? Well, my common ratio would be -6 divided by 3, which is -2, and if I check the next two terms, it is -2 again. So let's find the sum. Again, write out that literal formula. All right, we're finding the sum of how many terms? Well, 12 minus 3 plus 1 means I'm finding the sum of 10 terms. So the sum of 10. First term is 3. Common ratio is -2. The number of terms is 10 divided by 1 minus -2. And again, this is just a matter of, can you plug things correctly into your calculator? If so, you get -1023. All right, if you're having troubles with this, make sure you book some time with us or come and see us in person. We'd love, love, love to help you. Moving on. So the last thing we're going to do before we do a quick check is an application. So instead of making this a whole different section, we're just going to add it in. So this question says, if you asked for a starting salary of a penny, so my first term is a penny, a week, from your employer on the condition that it doubles every week, what would your annual salary be? So my first week I'd make a penny. My second week I'd make double that to make 2 pennies. My third week I would double that again so that I would make 4 pennies, and so on. Okay, I want to know what my annual salary would be. So my question is, are you finding an nth term, or are you finding the sum of n terms? Well, an annual salary is all the money that you've made in the year. So you'd be adding up your weekly wages. So we're going to find the sum. So if I wanted to find the sum of n terms, this is a geometric series because my common ratio is that I'm multiplying by 2. I put a1 times 1 minus r to the n. Let me make that neater. 1 minus r to the n. There we go. All over 1 minus r. All right, what was the first term? Well, we made a penny the first week. My common ratio was that I'm doubling. I'm going to have how many terms? Well, if you're getting paid a cent a week and doubling every week, there's 52 weeks in a year. So there's going to be the sum of 52 weeks. So n is 52 all over 1 minus 2. All right, plug it into your calculator and be absolutely blown away. So 0.01 bracket 1 minus 2 to the 52 unbracket equals divided by -1. Ready for it? 4.5 times 10 to the 13. So how much money is that? I looked it up one time. It's $4.5 trillion, which is pretty crazy. And one thing that, every semester I'm always like, oh, what if we looked at this? And it's crazy because you actually don't make that much for a very long time. It's only in those last few weeks that you're doubling a million and then doubling a billion and doubling a trillion. And it adds up really quickly. So some semesters we've gone in and been like, well, what was your weekly earnings in the 52nd week? If you are interested, it ends up as $2.25 trillion, right? So you make half of your entire trillion salary in that last week. But it's pretty cool. All right, so now you can do your quick check and we'll move on to the next video.